Alright guys, so we're going to talk a little bit today about isotope notation and calculating average atomic mass. So the first thing is we need to remember or relearn how isotope notation works and what isotopes are. So isotopes are atoms of the same element that have a different mass number because they have a different number of neutrons in their nucleus. So remember from atomic structure when you've learned it in the past that the protons and the neutrons in the nucleus of the atom are what give it its mass. Those are the two particles that have mass. Electrons do have some mass, but it's so small compared to the mass of a proton or a neutron that we just say that it's zero. And so these individual isotopes can be identified by using isotope notation, which is written using this diagram. So you have the chemical symbol of the element, and then in the bottom left-hand corner, you'll have the atom's atomic number, which is its number of protons. And then above that, you will have its mass number, which is the number of protons plus the number of neutrons. So here's an example of isotope notation for carbon-14, which is an isotope of carbon. So it has 6 protons, as we can tell from the atomic number 6 down here. And then it has 8 neutrons, because if I add 8 to 6, I will get 14. So if I take away 6 from 14, that gives me the number of neutrons, which is 8. Sometimes you'll also see isotopes written in hyphen notation, which is what this is over here on the right, where it's just the element symbol and the mass number following a hyphen. Because if you have a periodic table, then you will know what the atomic number is of the element. So sometimes they just shortcut and write it this way to identify an individual isotope. And so this is a mnemonic you might have learned before to help you with protons, neutrons, and electrons in a isotope. So 8-man. The 8 stands for atomic number, which is equal to protons, which is equal to electrons in a neutral atom. And then man stands for mass number, equals the atomic number plus the neutrons. And so if you can remember that, you can figure out the atomic number, the mass number, and the number of electrons in any element, or you can figure out what the element is or which isotope of the element it is using this mnemonic. Second thing we're going to talk about is calculating average atomic mass. So if you look at a standard periodic table, you'll notice that it's usually at the bottom of the element's square, right underneath the symbol, is its mass number. And that mass number for most of the elements on the periodic table is a decimal number. And isotopes themselves can't have decimal masses because you can't have a decimal of a proton or a neutron. That just doesn't work. So, how do we have this decimal number for the mass of the element? Well, that's because most elements have one or more, well, all elements have at least one, obviously, but most elements have 2 or more naturally occurring isotopes. And so each of those isotopes are not present in equal abundance. It's not 50-50, or if there's 3, it's not 33% all around. One isotope is usually more present than the others, and that's usually because that particular isotope is more stable than the others. So the mass that's on the periodic table is a weighted average of the individual masses and percent abundances of all of the naturally occurring isotopes of the element. It's kind of the same way that your grade in school is calculated, as 60% is your test grade average and 40% is your daily grade average. It's very similar to the way you calculate average atomic mass. So what you do is you take the mass of the first nuclide, which is another word for isotope, times the percent abundance of that isotope. And this is in decimal form. So when they give you percentages like this, you need to divide this by 100, or just scoot the decimal point left 2 places to convert it to decimal form. And then you would repeat that for the second nuclide times its percent abundance, and then just keep doing that for however many nuclides there are And then you just add them all together, and that's the average atomic mass. So in this example, we have two naturally occurring isotopes of boron, which is boron 10 and boron 11. Boron 10 makes up 19.9% of all boron and has a mass of 10.01 AMUs, which is short for atomic mass unit. Boron 11 makes up 80.1% of all boron and has a mass of 11.01 AMUs. And we want to know what the average atomic mass of boron is. All right, so before I even go to calculate this, I'm going to make a hypothesis that the mass is going to be really close to the mass of boron 11, because boron 11 makes up the majority of the isotopes or atoms of a sample of boron. So it would be a good bet that the average atomic mass of boron is going to be closer to 11 than it is going to be to 10. So we're going to go to calculate this. And I'm going to type it because I've learned that writing on these Jamboards just does not work well with my mouse. All right, so we're going to take the mass of the first isotope, which is 10.01, and we're going to multiply that by the percent abundance, and then I'm dividing that by 100 to convert it to decimal form. And then we're going to do the same thing again for the second isotope, 80.1 divided by 100. So then I'm going to switch over here to my calculator. So let's clear that out. Clear. So we're going to do 10.01 times 19.9 divided by 100 is 1.9919, but since this is only 3 sig figs, I'm just going to round that to 3 sig figs. So I'm going to put 1.99 plus, we're going to do that for the other, so 11.01 times 80.1 divided by 100 is 8.82 when I round that to sig figs. And so when I add those together, it's going to give me 10.81 AMEs. And so, number one, if I go to a periodic table and I look for boron on the periodic table, then it's going to match this average atomic mass that I calculated. And then number two, my hypothesis is borne out by the fact that this mass is really close to 11. It's a lot closer to 11 than it is to 10. So this probably is the correct way to calculate average atomic mass. So I can be fairly confident that I've done this calculation correctly. And so this is how you calculate average atomic mass.